Let's take a look at this one. I always like to put in the number, substitute it into the numerator and denominator just to see what form is it. Let's see. Let's put -4 into the numerator. You can do this in your head or in your calculator as well. I'll just write it down here for the video. -4 squared means -4 times -4, which is positive 16. And positive 4 times -4 is -16. So we get 0 for the numerator. How about the denominator? When I put -4 in there, let's see what we have. -4 times -4 times -4 is actually -64. And it turns out we have 0 as well. I just want to have a little warning here that if you wrote this down, that's wrong, right? Because, well, it'll give you the same answer in the end, but truly there should be a set of brackets there, right? I don't want to get too distracted with that, but whenever you put a number inside of for a variable, there's really a implicit set of brackets around it. And in the case of a cube, a negative cubed is still negative, but if a square, though, or an even power, it would change sign and you get the wrong answer if you didn't put brackets. All right, so anyways, this limit has the form 0 over 0, right? Let's... we could use L'Hopital's rule, but that's kind of overkill. We always should try to use the... if L'Hopital rule is not necessary to use, we shouldn't use it because it's more powerful than... Like, if you can solve the question with a technique that's simpler than L'Hopital's rule, then you should do that. And here we can use factoring, I think, because the top here is a common factor of x. And the bottom, what about the bottom? You know, x cubed plus 64 is actually a sum of cubes, right? Because 4 cubed is 64. And there's a formula for the sum of cubes, right? Do you remember what that is? Let's recall it here. A plus b cubed. How do we... Sorry, that's not it. It's a cubed plus b cubed. I sure hope you don't think that a cubed plus b cubed. I hope you know that these are not equal, right? That's basic algebra. But anyways, what I just wanted to quickly review is the formula for the sum of two cubes. We've talked about this before. It's equal to this, right? So it's kind of like I'm taking my a to be x and my b to be 4. So a cubed plus b cubed is the same as x cubed plus 4 cubed. It's going to be, according to this formula, it's x plus 4 times x squared minus 4 times x plus 4 squared, which is 16. So I'm going to substitute that in my limit here. And I have what I was hoping for, some cancellation. These x plus 4's cancel. And we have this. Now, can I put the -4 in now? Well, let's test it out. By the way, all this stuff I'm doing on the side here is just scrap work, okay? This is just for our little scrap work here. The main steps of the solution are being carried out right here. So we have, this is where we're at right now. Again, we have kind of like a fresh problem now. We have to look at this brand new and see what's really going on here. When I put -4 into the top, obviously I get -4. What about the bottom? When I put -4 in the bottom, let's work that out down here. You could do it in your calculator too. Notice I'm putting brackets around the -4 everywhere. You know, here's an example of what I was talking about before. If you wrote this down, you would get a wrong answer. Because -4 squared, written like this, is actually -16. But when you put brackets around it like this, it's positive 16. Let's see here. Let's see. 16 plus 16 plus 16. 48, right? Oh, so it looks like this is an easy kind of limit. We can just put -4 right in there. So we get -4 over 48. And let's divide top and bottom by 4 to simplify that fraction. And we get our answer to be -1 over 12. How about we do it with L'Hopital's rule? We're allowed to, right? It's 0 over 0. It's kind of overkill, but why don't we just try it with L'Hopital's rule as well and make sure we get the same answer? We better, right? So this is like method number 2. L'Hopital's rule. Let's see what we get. When we do L'Hopital's rule of the limit 0 over 0 form, we just do the derivative of the numerator and denominator separately. So we get 2x plus 4 for that top derivative. The bottom derivative will be 3x squared plus 0. And I won't even bother writing the 0. Now, can I put the number in? Sure. Because when I put negative 4 here, it does not cause me to have a 0 in the denominator, which is my main source of concern, and it's not going to be an issue here. So let's see what we have here. Negative 8 plus 4 is negative 4. And 3 times 6, positive 16 again, which is 48. And then similarly, we divide top and bottom by 4 to get negative 1 over 12. So this one is, both are good methods. It's sometimes good, though, to use the L'Hopital's rule is considered a powerful tool. And if you can solve the limit without a powerful tool and just use basic factoring, sometimes that's preferred by the teacher. But it's up to you or whatever your teacher requires. All right.